Hello everyone, and happy Saturday. Today is November 8th, and you're listening to your one and only San no Kane. I'm super excited for today's show. I've dug up a really cool training article from the archive that's going to totally blow your mind. So the title is PixCLIP, Achieving Fine-Grained Visual Language Understanding via any-granularity pixel text alignment learning. Woo, that's a mouthful, right? The course is taught colon/sarxib.org/abs/25 11.4600 It's long. Okay, so let's dive right in. First up, what's the problem this super smart paper is trying to solve? You've probably heard of an AI model called PixCLIP, right? It's like really famous for understanding both images and text together. It's pretty good at looking at a whole picture and a short caption and saying, yep, these two match. It has a couple of big weaknesses. Imagine you show PixCLIP a picture of a crowded park. You just want to talk about one specific little puppy playing with a red ball in the corner. The original PixCLIP model would get, like, totally confused. It sees the whole park, the trees, the people, everything. It can't just focus on that one tiny puppy you're interested in. And there's another thing. Life's text brain. Its text and matter has a super short attention span. It can only handle about 7 to 7 tokens, which is like a short sentence. If you try to give it a long, detailed paragraph describing the puppy, like a fluffy golden retriever puppy with a bright red ball, happily wagging its tail under a big oak tree, PixCLIP just can't process all that info. It kinda misses all the juicy, fine-grained details. So previous models struggle with focusing on specific parts of an image, and they couldn't handle long descriptive text. That's where our hero PixCLIP comes in. This paper is so cool because it basically gives PixCLIP a major upgrade, turning it into a super data for images and text. PixCLIP can understand images and text at any granularity. That means it can focus on the whole picture or a tiny, specific part of it, right down to the pixel level. How does it do that? Well, it uses something called a mask. You can think of a mask as like a digital stencil you place over an image to highlight the exact area you care about. So you can put a mask just around that puppy, and PixCLIP will know to focus only on what's inside that shape. And for the text problem, the researchers did something genius. They replaced Libin's old, limited text brain with a massive, powerful large language model, or LM. This new brain can read and understand super long and complex sentences. So you can describe the puppy in as much detail as you want. To teach this new AI, they also built a brand new dataset called LongGRIT. It is almost 1.5 million samples of images, with masks on specific objects and super detailed long-form descriptions for each mask part. That's right, they created a whole new textbook for the AI to study. Okay, so how is this, actually useful in their daily lives? This is the super fun part. Let's think of at least 3 examples. First, imagine you're watching your favorite show on Netflix or YouTube. There's a scene you loved, but you can't remember the episode. With PixCLIP, you could search for something incredibly specific. Instead of just typing, cat in a hat, you could type, a fluffy orange cat with green eyes, wearing a tiny blue top hat, sitting in a bookshelf next to a stack of comic books. The system would be able to find that exact moment in the video, because it understands both specific object, the cat, and your super long, detailed description of it. How awesome would that be? Second, think about interactive learning or VRM or training. Let's say you're a medical student using a VRM program to study the human heart. You could just point to a tiny valve inside the virtual heart and ask the system, what is the function of this specific bicuspid valve that prevents blood from flowing back into the left atrium? PixCLIP would understand exactly what part you're pointing at, and it would get the whole context of your long, technical question. What would make learning so much more interactive? and honestly way cooler. And for a third one, let's talk about online shopping and image search. You see a photo of a cool room on social media, and you love the lamp in the corner. Right now, you'd have to search for something vague like cool floor lamp. But with PixCLIP, you could literally draw a circle around just the lamp in the photo and search with a description like finding a tall, black metal floor lamp with 3 adjustable heads and an industrial style design, just like this one. What would make finding exactly what you want so much easier. So how does PixCLIP stack up against other technologies? Well, it totally leaves the original clip in the dust. Because it can handle those specific regions and long texts, which the old model just couldn't do. There are other models, like PixCLIP. PixCLIP was a good step, but it still struggled with long, complex text descriptions. PixCLIP. Secret weapon is using that big long for its text understanding, which makes it way better at connecting detailed language to specific image parts. The experiments in the paper show that PixCLIP achieves state-of-the-art, or SOTA, performance. It's basically at the top of its class, beating other models and tasks that need a really fine-grained eye for detail. In conclusion, PixCLIP is a huge step forward. It helps AI understand our world in a much more detailed and nuanced way. It's not just about looking at a picture anymore. It's about understanding the relationship between any part of an image and a rich, detailed story that we tell about it. This research is definitely going to open up tons of new possibilities for everything from search engines to creative tools. Well, what an incredible paper, right? It really feels like we're living in the future. That's all the time we have for today. Thanks for tuning in, everyone. This was your host, Sano Annie, and I'll catch you next time. Bye-bye.